Computing within limits is a research field that investigates how computing can operate sustainably within planetary, ecological, and resource boundaries. It challenges the assumption that current trajectories of ever-increasing production and consumption will continue indefinitely, recognizing that humanity faces fundamental planetary constraints related to climate systems, materials, and biocapacity. A practical example of computing within limits is found in low-power hardware design. Engineers are creating devices that meet essential computing needs while minimizing energy consumption. These systems prioritize longevity, repairability, and minimal resource use over processing power or feature growth. For instance, some organizations develop modular computers where individual components can be replaced rather than discarding entire devices, extending useful lifespans while reducing electronic waste and raw material extraction requirements. Computing within limits connects to several critical areas. It aligns with efforts to create sustainable infrastructure that prioritizes long-term ecological balance over short-term productivity gains. It directly addresses issues of material scarcity by rethinking how we design, manufacture, and dispose of electronics. Most importantly, it questions the default assumption in most computing research that ongoing economic growth is both achievable and desirable. Recognizing that this worldview conflicts with evidence from many scientific fields showing planetary boundaries that must not be crossed. Business models based on computing within limits present alternatives to growth-focused approaches. Some companies have adopted extended producer responsibility, taking ownership of their product's entire life cycle. This model provides incentives to design devices that last longer, use fewer resources, and can be easily repaired or recycled. By treating computing resources as finite rather than limitless, these businesses shift focus from constant replacement cycles to delivering lasting value through upgrades and repairs. Such approaches help reduce the ecological footprint of technology while maintaining economic viability. The computing within limits perspective transforms how businesses think about three key areas: resource accounting, innovation direction, and societal benefit. Accurate resource accounting requires businesses to consider the total material and energy impacts of their products rather than externalizing these costs. Innovation within limits prioritizes qualitative improvements that enhance well-being without increasing material throughput. Societal benefit becomes the primary objective, with economic gain serving this purpose rather than being the end goal itself. Together, these approaches may help businesses contribute to a transition toward systems that operate within planetary boundaries while supporting human flourishing.